Welcome, trigonometry friends. Today we will continue our variation on Johnson Jackson Pythagorean Theorem proof c squared equals a squared plus b squared. And we are going to do so not using a limiting process. I found that in mathstackexchange.com, URL below. So not using a limit. And the basic setup is the, well, you see the Johnson and Jackson famous triangle like this. And we continue this kind of a pattern. We mirror this triangle over. And so these are all similar triangles. And we construct a big triangle like this, which has alpha and beta. And here's beta, so this must be alpha. This must be beta minus alpha. This is B, this is B, so you got 2B. Here's C, here's C. We are after these two lengths, U and V, but we will not compute them using some infinite process, namely an infinite number of segments or triangles like we did previously. So that's our job, is find U and find V and not use the limit. And V, we're going to find that from H. H is from here to here, V is here to here. So V plus C is equal to H. And the other preliminaries, of course, we have sine alpha is A over C is cosine beta. Cosine alpha is B over C is sine beta. And our double angle formula, which we did previously in my previous video, well, that turns out to be 2AB over C squared. And the cosine beta minus alpha, that turns out to be 2AB over C squared, and sine beta minus alpha is B squared minus A squared over C squared. Those are the preliminaries. If need be, pause the video and convince yourself that these angles are so. Here's beta minus alpha, here's beta. And make sure this is all correct. There should be no tricks here. That's just plain triangle setup. So, okay, let's see, what do we have here? Basically, we have U is to sine alpha. U is to the sine of alpha using the law of sines, as 2B is to sine of beta minus alpha. See this? So U is, you plug in the ratio version, it's A over C times this 2 over B squared minus A squared over C squared. When you simplify, you get 2ABC over B squared minus A squared. Again, pause the video and do some math. Verify this is so. It's pretty simple and straightforward. Okay, so we've got that. That's one relationship. And here's another relationship. The H, this distance from here to here, is to sine of 90 plus alpha, and remember, alpha plus beta makes 90 degrees, and then plus alpha, so it's this big angle to H to this big angle, that's the law of sines, is the same as H is to cosine alpha. That's correct, because sine of 90 plus alpha is cosine alpha. That's a basic trig relationship, and need be, again, stop the video and convince yourself this is so. But cosines and sines are shifted by 90 degrees, so that's that. Okay, so we're doing law of sines, and that's the same as U is to the sine of alpha. That's, again, law of sines. So when we solve for h, in terms of the ratio versions, we get b over c times, here's u, that's 2abc over b squared minus a squared over sine alpha, which is a over c. Simplify this and you get 2b squared c over b squared minus a squared. Again, pause the video and do some math and algebra and verify that this is so. Should be. Okay. Next. So now we have to calculate what v is. Now we know that h is, so h minus c, that gives us the distance v. So let's see, v is h, 2b squared c over b squared minus a squared minus c, and then you've got to get the denominator in the same form, so multiply by b squared minus a squared. And when you simplify, you get c parentheses b squared plus a squared over b squared minus a squared. Again, pause the video and do some math and verify this is so. It's pretty simple. Okay, and from now on, look at this. Sine of 2 alpha is u to v, which is, here's 2 alpha, and so it's opposite to hypotenuse. This is a right angle. And so now you plug in what u is, which is right here, 2abc over b squared minus a squared. And what v is, c times b plus a squared divided by b squared minus a squared. I made a mistake. Okay. So now cancel things out, and you end up with 2ab over b squared plus a squared. Okay, now look at this. We know that sine of 2 alpha, these are the same, so these are equal. The numerators are equal. Therefore, the denominators must be equal. C squared must equal b squared plus a squared. So that's one proof, one way of looking at it. Another way is look at the angle cosine of beta minus alpha, which is again u over v, which we already know. And cosine of 2 beta minus alpha, well, that's the same thing. It's 2ab over c squared. Well, look, these are the same. Numerators are the same. Therefore, the denominators must be the same. C squared is b squared plus a squared. And that's the proof. I got that from MathStack Exchange. And I like it because it does not use this limiting process to find what u is and what v is. And I think that's a great improvement. So that's basically it. Thank you.